Most farmers will tell you, in a summer drought, the fields turn brown, the cattle starve, and the land itself cracks under the sun. Yet just over the fence, one patch of earth thrives, lush, green, bursting with protein-rich feed, and untouched by irrigation or annual replanting. This is not a miracle. It is the result of a forgotten tree that, once planted, can feed livestock every day for half a century. Scientists called it the alfalfa of trees, and a 19th century doctor believed it could end hunger. So why did nearly every agricultural institution turn their backs, leaving this superfeed hidden in plain sight? To understand, we have to go back to its volcanic birthplace, long before any feed truck rumbled across a dusty road. On the island of La Palma, the ground is shaped by fire. For millions of years, eruptions from Cumbre Vieja and the northern Garrafía Range have layered the land with fresh lava, leaving slopes of black rock and ash. In this raw landscape, most plants struggle to survive. Rainwater vanishes quickly. Soil is thin and poor if it exists at all. Yet among the jagged flows, a single shrub found its niche. Local farmers called it tagasaste. Botanists would later name it Chamaecytisus palmensis, a legume unlike any other. Tagasaste's roots do not stop at the surface. They push through pumice and basalt, sometimes plunging more than 10 meters deep. This ability to drill through rock lets the plant find water long after the winter rains fade. Where grass roots die out at a few inches, tagasaste draws life from the depths, thriving through droughts that turn the rest of the island brown. Its real secret lies in the air. The roots form nodules filled with bacteria that capture nitrogen from the atmosphere. Even on bare lava, tagasaste manufactures its own fertilizer, building soil where there was none before. Over decades, its fallen leaves and branches form a layer of rich earth, making the ground beneath it more fertile each year. Generations of La Palma farmers have watched this process unfold on terraced hillsides. What began as a scrubby survivor on volcanic slopes became the backbone of hillside pastures. In the harshest seasons, goats and sheep grazed beneath the tagasaste canopy, finding green forage when everything else had failed. The plant's resilience was more than luck. It was the result of evolution under relentless pressure. On an island where the land is born from fire and the rain is never certain, tagasaste became a living engine of renewal, quietly transforming rock into pasture and drought into survival. In the 1870s, a physician named Dr. Victor Perez saw something on La Palma that others missed. He was both a doctor and a farmer, someone who understood the needs of livestock and the realities of drought. While most agronomists looked to imported alfalfa or clover, Perez studied the wild tagasaste shrubs that thrived on the island's barren slopes. He began to document their value, writing treatises that described tagasaste as the alfalfa of the trees. In his eyes, this was not just a hardy survivor, but a plant capable of transforming agriculture in dry lands everywhere. Perez's conviction went beyond the written word. He gathered seeds from the oldest stands on La Palma and shipped them to botanical contacts beyond the Canary Islands. Among his destinations was the Royal Botanic Gardens at KEW, the world's leading plant exchange in the 19th century. The shipment records from this era show seeds arriving from the Canaries, part of a wave of botanical diplomacy that aimed to solve the food crises of the time. Perez hoped that by sending these seeds to Kew, he could spark a global movement, one that would see tagasaste planted on hillsides from the Mediterranean to the Australian outback. His campaign rested on a simple argument. Here was a tree that could outlast drought, feed animals through the leanest months, and build soil where none existed. Perez believed that the world's farmers needed a new kind of fodder crop, one that worked with the land instead of against it. He called for an end to the endless cycle of plowing and reseeding, urging others to plant tagasaste once and reap the benefits for decades. For Perez, the solution to famine and soil exhaustion was already growing wild on the slopes of La Palma, waiting to be recognized. But as his seeds left the island, they entered a world that was not yet ready to listen. Across Europe in the late 19th century, the idea of a tree as a fodder crop faced more than skepticism. It ran straight into the machinery of progress. Agricultural journals and policymakers praised the rise of annual crops like wheat, barley, and clover. These plants fit perfectly with a new generation of tools rolling out of factories, the combine harvester and the baler. The future, they believed, belonged to flat fields and straight lines, where machines could sweep across the land without pause. Trees, by contrast, were seen as obstacles, something to clear, not cultivate. Tagasaste, with its shrubby form and deep roots, did not fit the vision. Agronomists in Britain and France dismissed it as a curiosity, a relic of backward farming. The term peasant crop was often used, a label that carried both class prejudice and technological bias. In the eyes of the establishment, real progress meant uniformity and scale. Vast monocultures could be planted, sprayed, and harvested with ever larger machines. This mindset left little room for experiments with perennial fodder trees. Even as seed packets from the Canary Islands arrived at institutions like Kew Gardens, they were cataloged and set aside. The focus remained on annuals that required yearly seed purchases and matched the rhythms of industrial agriculture. The practical knowledge of hillside farmers who relied on tagasaste to survive drought was sidelined in favor of a model that measured success in bushels per acre and tons per hour. By the early 20th century, the push for mechanized efficiency had reshaped not just the fields, but the very definition of what counted as a crop. Tagasaste faded from view in the West, ignored not because it failed, but because it did not fit the machinery. In this vacuum of official interest, its story drifted, waiting for a chance to prove itself beyond the reach of plows and combines. Tagasaste's journey beyond La Palma was never part of any grand agricultural plan. In the late 1800s, as ships carried people and goods from Europe to the far corners of the world, seeds found their own way into new lands. Some accounts suggest that miners traveling from the Canary Islands tucked a handful of tagasaste seeds into their pockets, hoping for a taste of home on the goldfields of Australia. Others point to crates of fruit and wool packed with dry leaves and pods, with seeds slipping unnoticed into the sandy soils of a distant continent. Whatever the exact route, the plant's arrival in Australia and New Zealand went almost unremarked. There were no headlines, no official trials. Farmers ignored it at first, dismissing the wiry shrub as another oddity in a landscape already full of unfamiliar plants. But tagasaste did not need an invitation. In the poor, acid sands of the Western Australia wheat belt, where English ryegrass and clover withered, it quietly took root. Over the next decades, naturalized stands began to appear on neglected paddocks and roadside verges, oases of green in a sea of yellow dust. Field notes from early 20th century agronomists record the surprise. Here was a plant thriving without irrigation or fertilizer, shading out weeds and surviving summer heat waves that scorched everything else. Local graziers started to notice that sheep and cattle would seek out these stands, stripping the leaves even when other forage was gone. The evidence was plain for anyone willing to look. Tagasaste had proven itself, not in the columns of scientific journals or at agricultural fairs, but in the hard-fought soils where survival was all that mattered. For some, it was the first hint that the old rules about what could and couldn't grow on marginal land might not be so fixed after all. Grassroots rarely reach beyond a foot beneath the surface. In the heat of summer, that shallow reach leaves pastures gasping for moisture, their growth stunted as the soil dries and cracks. Tagasaste operates on a different scale entirely. Its taproot is engineered for survival, drilling down through sand, gravel, and even volcanic rock. Field trials and farmer accounts report roots plunging as deep as 10 meters, over 30 feet, well beyond the reach of any competing pasture plant. This underground descent is more than a feat of endurance. It grants tagasaste access to water reserves untouched by drought, allowing the plant to stay green and productive when the rest of the landscape withers. But water is only half the story. As the roots snake downward, they tap into mineral layers that ordinary crops never reach. Calcium and phosphorus, locked deep in the subsoil, are drawn upward and deposited on the surface through a steady rain of fallen leaves and twigs. Over time, this natural cycling transforms poor, sandy ground into richer, more fertile earth. The process is slow but relentless. Each year, a new layer of organic matter builds beneath the tree's canopy, darkening the soil and feeding the next flush of growth. This root-driven system explains why tagasaste stands out as an oasis in the midst of drought. Where neighboring fields turn brittle and brown, the tree's deep reserves keep it lush and green. The mineral uplift not only benefits tagasaste itself, but also enriches the pasture around it, supporting other plants and ultimately the animals that graze beneath its branches. In landscapes where every drop of water and every scrap of nutrient counts, the 10-meter taproot is not just an adaptation, it is the foundation of resilience. Laboratory analysis of tagasaste leaves delivered a surprise to even the most skeptical farmers. Tests showed crude protein levels between 20 and 30%, on par with the best lucerne or alfalfa hay. Digestibility scores hovered around 65 to 70%, meaning livestock could convert nearly every mouthful into energy and muscle. For a plant that survived on bare volcanic rock or sandy Australian paddocks, these numbers seemed almost impossible. Yet the feed tests were clear. Tagasaste was not just a backup for tough years, but a genuine rival to the most expensive commercial forages. The economic advantage became even more apparent when farmers compared their annual budgets. Traditional fodder crops demand a yearly cycle of plowing, seeding, fertilizing, irrigating, and harvesting, each step burning diesel and tying up labor. Tagasaste changed the equation. After the first year of careful establishment, there was no need for tractors or balers. The cows did all the harvesting themselves, stripping the green leaves straight from the branches. Over the lifespan of a stand, often 40 to 50 years, this shift cut diesel and machinery costs by as much as 80%. One Western Australian rancher tracked his fuel bills and found that, after switching a portion of his land to tagasaste, his annual diesel use for fodder dropped from thousands of liters to just a few hundred. The savings went straight to the bottom line. Protein-rich leaves, perennial growth, and a management style that replaced machines with hungry cattle, tagasaste offered a kind of lazy efficiency that most farmers could only dream about. For those willing to plant once and wait, the payoff was clear: more protein per acre, less time in the tractor seat, and a feed reserve that outlasted drought and market swings alike. By the early 1980s, tagasaste's reputation had taken an unexpected turn. In regions like California and parts of Western Australia, environmental agencies began to scrutinize the shrub's rapid growth and its ability to reseed itself far from where it was planted. Official documents from the California Department of Food and Agriculture listed tagasaste as a potential threat to native bushland, labeling it an invasive species. Similar warnings appeared in Australian state registers, where the plant's ability to colonize poor soils raised alarms among ecologists. For regulators, the concern was clear. A forage tree that could outcompete native plants on marginal land might disrupt fragile ecosystems. The response was swift. In many districts, tagasaste was banned outright or subject to strict controls, making it illegal or highly discouraged to plant on new farms. These policies did not just slow adoption, they created a chilling effect. Farmers who saw the cost savings and drought-proofing potential now faced fines or the threat of legal action. For many, the risk was too great. The plant that once promised resilience became a legal gray area, its future shaped as much by policy as by biology. Modern agriculture is built around machines that demand uniformity. The combine harvester, perfected in the late 1800s, was designed to sweep across endless fields of wheat or barley. cutting and collecting in a single pass. Every acre had to be flat, open, and free of obstacles. Trees, especially rows of deep-rooted fodder like tagasaste, simply do not fit into this system. A combine cannot maneuver through a living hedge. Balers and seed drills are useless in a landscape dotted with shrubs. For industrial-scale farms, this incompatibility is more than an inconvenience. It is a barrier that shapes what can and cannot be grown. The economics reinforce this divide. Annual crops like corn and soybeans require farmers to buy new seed every year, fueling a cycle of recurring sales for global seed companies. Tagasaste, by contrast, is a perennial investment. Once planted, it can provide fodder for 50 years without a single repeat purchase. There is no incentive for seed companies to promote a crop that eliminates their own business model. Without a marketing push or machinery designed for tree-based systems, tagasaste remains sidelined, outperformed in advertising, not in the field. The silence around this superfeed is not just a matter of policy or ecology, but of profit and the machinery that underpins modern food production. Beekeepers in Western Australia talk about tagasaste as a lifeline for their hives. When winter starves the landscape of flowers, these trees burst into bloom, filling the air with bees and producing honey at a time of year when most colonies struggle to survive. For ranchers, the benefits stretch far beyond fodder. Rows of tagasaste act as living fire breaks, dense, green, and moist even in the height of summer. In wildfire-prone districts, these hedges have slowed grass fires, protecting paddocks and livestock where dry pasture would have fueled disaster. But success depends on patience and skill. The first year is critical. Seedlings must be fenced off from rabbits, deer, and cattle. Rush the process, and the young trees don't stand a chance. Even after establishment, management is an art. Cattle will strip bark if left too long, so graziers rotate herds frequently, moving them before curiosity turns to destruction. Meanwhile, researchers studying the tannins in tagasaste leaves are finding another benefit. Cattle grazing these shrubs produce less methane, hinting at a climate solution rooted in tradition. For those willing to adapt, the rewards are as varied as they are lasting: protein, honey, safety, and the promise of a smaller carbon footprint. As droughts intensify and feed costs soar, the choice to ignore resilient crops like tagasaste grows less sustainable by the day. Every year, millions of acres risk desertification, while a proven living fodder quietly waits at the margins. The real secret isn't the plant, it's our reluctance to change the model. Sometimes, feeding the future means daring to break the mold. What's your take? Share your thoughts below.